random variable y has a Poisson distribution with mean m and satisfies py equals 3 equals py equals 1 plus 2py equals 2. We need to find the value of m correct to 4 decimal places. So the 4 decimal places part implies that in the end we're going to have to use a calculator. The way it's set up in such a way that we have to use the probability generating function, which is quite nice, and we're going to do it a bit of algebra. So y is distributed according to a Poisson distribution, and it has a mean and variance of m. The parameter is m. M is the thing we need to find. Py equals 3 equals py equals 1 plus 2py equals 2. So py equals y equals, if you go straight to your formula book, it tells you px equals x equals m to the power x e to the minus m over x factorial. So we're going to have m to the y e to the minus m over y factorial. So then we just write down everything we know. So py equals 3 in terms of this. So that would be m to the 3 times e to the minus m over 3 factorial. So that's py equals 3, and we're told this equals py equals 1. So equals py equals 1 would be m to the power 1 e to the minus m over 1 factorial plus 2 times py equals 2, which would be m squared e to the minus m over 2 factorial. So you can see some quite good things are going to happen now. Firstly, you have in all 3 terms, you've got this common factor of e to the minus m. So I'm just going to divide through by e to the power minus m, just like that, which will make things a lot easier to deal with. And secondly, you've got this 2 over 2 factorial. Well, 2 factorial is just 2 times 1, so this cancels nicely, the 2 with the 2 factorial. 1 factorial is just 1, and m to the power 1 is just 1, so this now is, also 3 factorial, 3 times 2 times 1 is 6. So this is m cubed over 6 equals, so this term is just m plus, and this now is just m squared. So if I just multiply through by 6 first, that would be m cubed equals 6m plus 6m squared. So I'm looking to, normal approach would be to make this thing equal 0 and see if we can factorize. So I would say m cubed minus 6m squared minus 6m equals 0. You have a common factor of m in all of these. You don't want to be dividing through by m, because it's bad practice anyway. So I'm going to say m squared minus 6m minus 6 equals 0. So now at this point we look to factorize the quadratic, and you see that it won't factorize, hence why we need a calculator really. So we know that m either equals 0, which doesn't really make any sense, or m squared minus 6m minus 6 equals 0. Seeing as this is a nice quadratic, I might even just go for the quadratic solver. So menu, if we go down to equation, the polynomial solver in F2 is degree 2. It's not the only way to do this, but I'm just going to put so ax squared plus bx plus c. A can be 1, 1x squared plus minus 6m, so b can be minus 6, plus c is also minus 6. So m squared minus 6m minus 6 equals 0. Press solve, and you get 2 numbers. So m is either 6.8729. What did we ask for? 4 decimal places. 6.8729. or m equals minus 0.872. Well, if you think of what this is m is a mean, and remember this is the amount of occurrences of a physical thing. What the Poisson distribution models it's the amount of times things happen. It's a discrete distribution. You can't have a negative amount of times things happen in a window, and you're not going to have zero either. So the m we are going to use is 6.8729, so we will disregard this one.